Welcome to thermionic emission. Thermionic emission is a phenomenon whereby a heated wire emits electrons from its surface. You will be familiar with the idea of electrons leaving the surface of a metal because you've studied the photoelectric effect, and we will be talking about the work function. This phenomenon was first noticed by Henri Becquerel, a French physicist, in 1853. Later, in 1873, a British physicist called Frederick Guthrie noticed that if you have an object, a metal object that's got negative charges, and you heat it up, then what happens is that it loses its charge. And that's because the charges are emitted from the surface. The electrons escape because they have enough energy to escape. Guthrie noticed that if you do the same experiment, but you have the metal object charged in a positive way, you can heat it to a very high temperature, but those positive charges will stay there. Another British physicist called Owen Richardson received a Nobel Prize in 1928 for his work on thermionic emission, where he discovered that the number of electrons given off depends on the temperature of the wire and the work function of the metal. And lots of work was done by him and his colleagues to reduce the work function of the metal by applying coatings and treating the metal in lots of different ways. Because of course, if you can reduce the work function, then you don't need as high a temperature and you can save energy. If you put a barrier in place, then what happens is that the electrons that collide with the barrier are absorbed, but those that make it through the gap are ejected in a straight line. And you have now created an electron gun, also known as a cathode ray tube, or a CRT. If you put a charge on this barrier, a positive charge, then the electrons will be attracted toward it, and those that fly through the gap will have been accelerated to a very high velocity indeed. This kind of technology was used by William Bertozzi in the 1960s to accelerate electrons to an extremely high velocity, close to that of the speed of light, in order to test and prove Einstein's theory of special relativity. We can calculate the velocity of an electron accelerated in this way by using the following equations. Remember that when an electron is accelerated, all of the work done on it is done to increase its velocity. So the work done by accelerating the charge through a voltage is going to become its kinetic energy. So the voltage between the element and the plate is this value here, and this is the charge of the electron. So the equation becomes this. And if you rearrange for velocity, and of course this mass is the mass of an electron.